Hello my dear students, this is P. Venkateshwarlu, PGT Physics. In previous video, we have to learn the Bernoullis Theorem, which is very important one. Okay, so once again you can recall it. So before that you can understand that now. Okay, if not I am able to explain more times. Okay, and otherwise so you have to see the same video repeatedly. Okay, so understand. So those who are not understanding that type of big derivation, so at least you remember the statement and formula. At least you remember statement and formula. So coming to Bernoullis Theorem statement. Okay, once again after that we are going to applications of Bernoullis Theorem. Okay, Bernoullis Theorem. Bernoullis Theorem. Bernoullis Theorem. Bernoullis Theorem states that the sum of the pressure energy per unit volume, potential energy per unit volume and kinetic energy per unit volume of an incompressible non-viscous fluid in a streamlined irrotational flow remains constant at every cross section throughout the liquid flow. Okay, once again my children, the theorem or the statement is the sum of the pressure energy per volume, potential energy per volume and kinetic energy per volume of an incompressible non-viscous fluid in a streamlined irrotational flow remains constant at every cross-section area throughout the liquid flow. Okay, from the statement we have to write equation. Yes, pressure energy per unit volume, potential energy per unit volume and kinetic energy per unit volume is constant. Understand my children? Understand? Okay, this is the important statement. Okay, suppose, so we have to take that pipe above the earth surface. So we can observe many situations, the pipe is on the earth. Okay, like this. So this is the earth. Okay, here we have to take pipe. Okay, so what happened? The equation. Okay. So H is equal to 0. H is equal to 0. The condition is H is equal to 0. In this case, what happened? P plus rho G into 0 plus 1 by 2 rho V square is equal to constant. Okay, in this case, pressure plus 1 by 2 rho V square is equal to constant. Okay, so in this case, suppose here P is the pressure, rho is the density, my children. Density. Okay. So understand V is the velocity of the fluid. In this case, whenever the fluid flows horizontally, which is irrotational, non-viscous fluid, in this case, if pressure increases means velocity decreases. Understand? According to Bernoullis theorem means what happened? Pressure increases means velocity decreases, vice versa. Okay, understand my children? Pressure increases means velocity decreases, vice versa. Or velocity increases, pressure decreases. Understand my children? Suppose we have to take another example. If fluid at rest, what happens? Okay, fluid is at rest. Some cases fluid at rest. Fluid at rest means what happens? Velocity 0. Okay, velocity 0. We can say fluid at rest. Understand? You can write this one. P1 plus rho G H1 plus 0 is equal to P2 plus rho G H2 plus 0 is equal to that. Okay, understand? Rearrange this. P1 minus P2 is equal to rho G H2 minus rho G H1. Okay, P1 minus P2 is equal to rho G H2 minus H1. Okay, understand this expression. This expression we can get pressure due to variation of depth. Okay, pressure due to variation of depth. Okay, understand? So consider a container, consider a fluid. Okay, so we can take one object. The object is immersive. Okay, so in this case we have to find the pressure. Here the height is H1. Here the height is H2. Okay, here pressure acting. Here P1, here pressure acting P2. Okay, so in this case H2 minus H1 is equal to H. From this pressure due to variation of depth, we can write rho GH. Rho GH. Understand? So in this way, Bernoullis theorem are useful. Okay, so in previous we can find the pressure due to variation of depth. We can by using different method we have to find. Here from the Bernoullis theorem also useful to find the pressure variation with the depth. Okay, my children? Yes. Okay, many applications is there, my children. Okay, so many applications. Now we need to discuss about. Now we are going to discuss about applications of Bernoullis theorem. Applications of Bernoullis theorem. Applications. Bernoullis theorem applications. Okay, coming to first one, my children. First application is Venturi meter. What, my children? Venturi meter. Venturi meter. Okay, so Venturi meter is a device which measures the Venturi meter is the device based on the principle of this Bernoulli. Okay, so it is an instrument or it is one of the appliances measure the flow of speed of the incompressible fluid through a pipe. Okay, so what, my children? This is an instrument measure the flow of speed of incompressible fluid through a pipe. Okay, so in generally if a pipe having water which flows, okay, understand? So if water flows, if any fluid passing through any container, this pipe, the flow of speed, how we can find means by using Venturi meter. Venturi meter is a device to measure the liquid flow, liquid or fluid flow, liquid or gas flow in that particular pipe. Okay, so based on the principle of Bernoullis theorem, mentioned. Next, atomizer or sprayer. Second one. Atomizer or sprayer. See here, atomizer or sprayer. Okay, so this is also one of the applications of Bernoullis theorem. Okay, see here in this case, so we are regularly using this sprayer. Okay, understand? So we know that okay, perfume, how we can use perfume. Okay, so in many cases how sanitizer will come out. Okay, so by pressing, so sprayer, by using sprayer, my children. Okay, so I will explain how you can use any perfume and this sanitizer, how by pressing how it will come. Okay, understand? So I consider one of materials, okay, one container like this. Consider a pipe. Okay, see here we can take fluid in the container, okay, by pressing, what happens? See here, by applying force, so what happened, my children? Okay, so by applying force, the speed of the fluid moves faster, the fluid inside the container. Okay, this is liquid, this is fluid. Here also a fluid is there, that is air. Okay, so if we can compress the container, what happens? Velocity increases. What might children? Velocity increases. If we compress this container, means what happens? Velocity increases. Understand? So velocity of the fluid increases. Okay, so here in this case also velocity increases. Understand? So when velocity increases, what happens? Pressure decreases. Okay, here inside the fluid, pressure decreases. Okay, so when pressure decreases means what happens? Due to low pressure, okay, the liquid, the fluid come out. Understand? So the fluid come out. Okay, so when fluid come out from the lower end to upper end, okay, so if the application of velocity moves faster, the particles moves faster. Okay, understand? The particles moves faster because velocity increases, pressure decreases, the fluid come out from the container. Okay, so even though the velocity will not decreases, due to the velocity, particles are moves out, and because of the less pressure of the container, the fluid come out, and because of here air collide with these particles, the sprayer work out. Okay, understand? The particles are splitting in different direction. Okay, so this is the mechanism of for refilling bottle and sanitizer and etc. So what are the liquids we can use by compressing? Okay, understand, my children? Next application, blood flow. Okay, next one, my children, what, my children? Blood flow, my children. Okay, so we know that so the blood flow. So by using Bernoullis principle, we have to find blood flow. Okay, so we know that Bernoullis theorem, that is pressure energy per unit volume, potential energy per unit volume, and kinetic energy per unit volume of an incompressible non-viscous fluid. In streamline flow, irrotational flow remains constant throughout the all cross-section area, throughout the liquid flow. Okay, my children? So next, coming to applications, dynamic lift. Dynamic lift, my children. Coming to dynamic lift. Dynamic lift is the force that acts on the body by virtue of its motion in a fluid. Okay, so dynamic lift is the amount of force, okay, which acting on a body when the body moves in a fluid. Understand, my children? So what is dynamic lift? Okay, when a body moves in a fluid, okay, some force is acting on the body. Okay, due to that force, the body may move in curved path, moves upward direction. Okay, so that force is called dynamic lift. Okay, so consider an example. Consider an example. So consider a ball moving in a fluid without spinning. Without spinning. Okay, so we know that ball moves rightward means the fluid moves in opposite direction. Okay, so in this case, above and below the fluid velocity is same. Okay, so velocity is same. So and above and below speed is same. Speed is constant. Okay, so if speed is constant, there is no external force on the body. Okay, so body moves in a straight path. Understand? If the ball is spinning, okay, so what happened? Okay, what happened, my children? If the ball spins, okay, understand? Now, ball spins like this, okay. Okay, so if the ball spins means what happened? Okay, so above the ball, velocity decreases. See here, above the ball, if the ball is spinning, above the ball, the fluid flow is increases, velocity increases. Understand? So due to this pressure decreases. Understand? Next, below the surface of the ball, okay, velocity decreases, then pressure increases. Okay, so whenever pressure acting on the ball, so what happens? Ball moves up. Okay, understand here the dynamic force which is acting on the ball, so which make the path of the ball moves in a curved path. Okay, understand, like this curved path. Understand, my children? Here dynamic lift is the force which is acting on the body when the motion of the body inside the fluid. Okay, so if the ball moves without spin, okay, so above and below the fluid flow is same, so there is no net force acting on the ball moves in straight. So when the ball is spins what happens? Above the surface of the ball, speed increases, pressure decreases. Here below, velocity decreases, pressure increases due to, so what, the ball is spins. Due to this dynamic forces act, okay, which makes the ball moves in a curved path, which makes the ball moves upward. Okay, understand, the force will acting on the body which moves up. Okay, that we can say dynamic lift. Okay, dynamic lift. Understand? Next, aerofoil, lift off an aircraft wing. Lift off an aircraft wing. Aerofoil. Lift off an aircraft wing. Okay, understand aerofoil, lift off an aircraft wing. Okay, see here, we know that wing of aircraft. Okay, see here. Okay, this is aircraft wing, we can say aerofoil. Okay, so in this case, when this airplane moves, okay, so what happens? Above aerofoil, fluid flow like this. Okay, in this way. Understand, below the aircraft wing, okay, the fluid flow is less. Here velocity increases, here pressure decreases. In here below the surface, velocity decreases. When flows this type of aerofoil flows in the fluid, velocity decreases, pressure increases. Due to pressure increases, what happens? The aircraft wing will move upward direction by itself. Understand? Here, this is the aerofoil. Okay, when aerofoils moves in a fluid, so above the surface, the fluid speed increases. If speed increases means pressure decreases, and due to this, what happens? So due to this, what happens, my student? So below the surface, velocity decreases, then pressure increases. Due to this, aircraft wing move upward. So based on the dynamic lift. So okay, my dear children, these are the applications of Bernoullis theorem.